Question: the circle C has equation x squared plus y squared minus 8x minus 10y plus 16 equals 0. The center of C is at the point T. For part A, we need to find the coordinates of the point T, and for part I, we need to find the radius of the circle C. So we start by first writing the expression, the equation of the circle. We have x squared plus y squared minus 8x minus 10y plus 16 equal 0. So now we will attempt first to rearrange the expression so that the y's are grouped together and the x's are grouped together. So we can rearrange this to x squared minus 8x plus y squared minus 10y plus 16 equal 0. And then we will rearrange this again, so where we can see that the x squared minus 8x, that's a square completed, so that will give us x minus 4 squared, and also as part of it, we would have 16 here. And we can see also the y squared minus 10y is another square completed, so that will give us y minus 5 squared minus 25, and we have a plus 16 here equals 0. So we can see that there is a minus 16 here and a plus 16. So these two will be eliminated. So that will give us the equation being x minus 4 squared plus y minus 5 squared. And we will move the minus 25 to the right hand side, so that will give us plus equal 25. So from here we can see the coordinates. So we can see that the t coordinate will be the x. We move the because it's x minus 4, it becomes the point. The first coordinate of the x coordinate is 4, and we have also from the y, so we can write it in a better way. So from here we have x equal 4, and from here we have y equal 5, and from here we have r equal 5. So what we would have in this scenario, the t coordinate will be the x coordinate is 4 and the y is 5. And for C, we have all the radius of the circle, the r would be 5, as we've taken the square root, as this typically in the equation it's r squared. And this will be our answer for part I, and this is our answer for part I. For part B, the point M has coordinates of 20 and 12, and we are, as part of B, we are asked to find the exact length of the line MT. So we look at part B here. So in this scenario, we say that the MT will be taking the square root of, in this scenario, using the equation, we have x take away the x coordinate here, which is the point of 20. So this is the x and this is the y. So we would have 4 take away 20 squared plus we have y, which is 12 take away 5 squared, and this will be in the scenario our answer. So we have the x take away 4, so that will be in the scenario 20 take away 4. So in the scenario, when we simplify this expression, it should give us the root of 305, which will be our answer for part B. For part C, point P lies on the circle C such that the tangent at P passes through the point M. And so for part C, we need to find the exact area of triangle MTP, giving your answer as simplified as a simplified third. So for us to first, for part C, we need to find M, which is represented in the form we found, MT. So in this scenario, it will be the root of 305, because it will be squared. So that means the root will disappear, or we can write it as the root of 305 squared, plus we have the circle, which is 5, the radius of the circle, which is 5 squared. So that will give us 2 root 17. So now for us to understand how does that work and how, So if you imagine the circle in this format, and we have the tangent line like this, and we have the center of the circle, which is 4, 5, so this is the 5, and we have also the line like this, which represents the point root of 305, and this is the 5, and this is the right angled triangle, and we have point P here, and this is T, and this is the point M. So we were able to find, we have 5 and root of 305, so this is what we use to find the length of PM as shown here. Now to find the area of PMT, it will be, so the area of PMT, it will be half the base by height. So in this scenario we have half multiplied by 2 root 70 multiplied by 5, so that will give us in this scenario 5 root 70, because these two will disappear, and that will give us 5 root 70, and this will be our answer for part